Paper 1R, June 2016, question 7. This question is about refraction. So the first question is a practical one. The student is using a semicircular glass block to investigate refraction in glass. Give 3 other pieces of equipment. So keep it simple here. Things that we're going to need. Number 1, some kind of light source. I'm going to say a ray box, but light source would be absolutely fine. Number 2, you're going to need something to draw the rays with. So pen, pencil, paper, something like that. Like I said, it's a pretty easy question. And the third thing you're going to need to be able to get your results is a protractor. Don't forget that one. So part B. On the diagram, draw the normal at P. So the normal is a line that is perpendicular at a right angle to the surface that we're talking about. So if we're talking about this surface here, where we're going from air into glass, then drawing the normal means that you need to draw a line where the ray meets the surface at 90 degrees to the surface. And again, if you're artistically challenged like me, put that little sign in there for the right angle so they know what you're trying to draw. So measure the angle of incidence and the angle of refraction. So we've drawn the normal for a reason. Any angles that we measure are always measured to the normal. So the angle of incidence is this one, and the angle of refraction is that one. Now be careful when you're using your protractor. Make sure that your answers are sensible. So if you're using your protractor properly, looking at I, it's probably going to be about 45 degrees-ish. If you're getting an angle that's 135 degrees, obviously you're doing something wrong. So just be sensible and check your answers. Same thing for the angle of refraction. It's obviously going to be, I don't know, looks like 30-ish, just judging by eye. So if it's anything much, much bigger than that, then check again. So for number 3, explain why the ray of light changes direction at P. Now you can't have refraction because it says that in the question. So while that's right, we need a little bit more detail. So why is it refracting? So the reason it's refracting is because it is going from one medium, one material, to another. So it is going from air to glass, a change of medium. That's for your first mark. Second mark is for saying, why does it change direction? So what happens to the light when it goes from one medium to another? And the reason is because there is a change in speed. Now you can say that it slows down because that is what happens. It goes from air into glass and it slows down, or a change in speed will do just fine too. Now that's all you need for the marks. If you wanted to go into a bit more detail, you could put an extra bit in here about the fact that the refractive index has changed. So it has gone into a higher refractive index when it travels into the glass. But for 2 marks, you don't have to have that. For the second part, you could also put something that there is a change in wavelength, but speed is the easier answer. So as always, it's a physics paper, so we've got to have some kind of a graph in there. And you have a table of results where you've got angle of incidence, angle of refraction, and then they've taken the signs of those angles there as well. So it wants you to plot a graph of sine I against sine R. Stick to the usual rules when you're plotting the graph. Labels on both axes. It actually doesn't matter which way round they go. I'm going to put sine I on the bottom and sine R at the side. Now, usually for a graph, you've got to be really careful about units. But because they're angles, they don't have a unit or the signs of angles. So we don't need to worry about that for this graph. you've got to have a correct scale on both axes and use the whole grid, or use at least more than half the grid either way. If it's too small, you'll lose marks. So I would go for, see, that's 0 and up to 1 over here. They've made the numbers quite nice for you. It's not too tricky. So that'd be 0.2, 0.4, 0.6, 0.8, and the same scale up this side as well. Make sure you've got your 0 on there. Lots of people forget that. Okay. And then you're plotting, so with small crosses, please. Now I'm just going to plot vaguely in the right place because this is not the best pen that I'm writing with. Even so, I bet I'm still neater than a lot of your graphs will be. On there, and kind of vaguely there. So it wants to be a straight line of best fit. Remember, when you're doing things like this, if it says draw a line of best fit, it doesn't have to be straight. It can be a curve if it looks like that's what the data wants it to be. But this does look like a straight line. So use a ruler and try and draw a straighter line than that one. So state the relationship between refractive index, angle of incidence, and angle of refraction. This is Snell's law, which you learnt, or a variant of Snell's law. So the version that we taught you is that refractive index, which has the symbol n, you can just write it out in words, is sine I over sine r. But remember, that is for a ray going from air into something with a higher refractive index. And then it says, use your graph to find the refractive index of glass. So the way round that I've drawn it is actually not that helpful, because I want to do sine I over sine r. If I'd done it the other way around, hopefully you would have noticed that it was actually the gradient, because that would have been, if I'd done it this way round, it would have been sine I divided by sine r. But it doesn't really matter. What you can do is just take two values, take them from the line, any two values, and do one divided by the other. Make sure it's from the line. So for example, this point here, because of the terrible way I've drawn this graph, is not actually on my line of best fit. So I wouldn't choose the values that go with that point. But this point here, okay, that one's right on the line of best fit. So if I chose the values for that point, that would be okay. The easiest thing is pick some nice round values. I'm going to say that sine I there is 0.6 and sine r is 0.4. And if you've done this properly, your answer should be somewhere between 1.54 and 1.60.